So this video is going to be about power. There's also a very specific basic physics definition of the word power. We can't use it any old way like we do just in the English language. In physics, power is the rate at which work is done. So anytime we're talking about rate, we know time is going to be involved. So the equation for power is P equals W over T, where W is work. We just talked about work and how to figure that out, divided by time. So an example might be the running the stairs lab that we did, and you worked through all of this math with your own example there. So let's talk about that experiment in more general terms as we discuss problem solving related to this. Let's say that we have a kid who weighs 100 kilograms, and let's say that our stairway is 5 meters tall, just to keep the numbers friendly and easy to deal with. So knowing that power equals work times time, we need to find work first. Work can be found by multiplying the mass of the kid, 100 kilograms, by the distance up he went, right? So that's 5 meters. So 100 times 5 is 500. 500 joules is the amount of work that's done. Now we're up to talking about power. Do you think it was going to take more power for him to go fast or more power for him to go slow? This should be pretty intuitive, right? A more powerful person should be able to haul themselves up those stairs more quickly. Let's see if that works out with the math. If we take that 500 joules and divide it by, say, 5 seconds, that means that our stair runner is using 500 divided by 5 is 100 watts of power. So what if our stair runner takes 50 seconds? 500 divided by 50 is 10. That's 10 watts of power. Much, much lower. So we can see that, yeah, our intuition is right here. Work being done very quickly requires more power than work being done very slowly. Here's the math. Let's see. There we go. Power is the rate at which work is done. We can say power equals work over time, or P equals W divided by T. I forgot to write on here, but power is, the units are watts, which is abbreviated W. Don't confuse watts and work when you see a W. Really careful about that. So here's our problem worked out, or one that's very similar to the one we just discussed, comparing the power needed by the same kid to run up the same distance, but in different lengths of time.